How many of you guys actually found this was kind of difficult to do without a coordinate plane? It's difficult. What I want to do is I'm going to kind of be at your level. Just because I have a nice graph doesn't mean you need it. So I'm going to get rid of this. Now, that doesn't mean it's over. Okay? The easiest way to handle these type of problems, if you're given nothing, okay, is to still try to draw something out of it. If I'm drawing a coordinate plane like this, let's just graph these points really quickly. Okay? Back 6, down 2, so let's say 6 and 2 is down here at A. Back 2, up 3, let's say it's B's up here. C is at 3, negative 1. And D is going to be back 1, down 6. So if we just roughly, I'm not even putting the coordinate points of these, okay, we can roughly see how it's going to look. Is it 100% accurate? By all means, no. But it gives you an idea of what type of sides are going to be congruent or parallel, what things you're going to be looking for. Okay, is it a quadrilateral? Absolutely. Has 4 sides to it. But we're going to be able to tell a little bit more about this. Okay, now prove the quadrilateral ABCD is a parallelogram. By definition, what we had on your guys' paper, what does it mean to be a parallelogram? Two parallel sides. That means we need to have 2 groups of 2 slopes that are parallel. Okay, so once you guys have a picture on this, and I know it's not 100% accurate, but it's going to help us out. One thing that I'm looking at is I know AB should be parallel to CD. So we're going to actually put those side by side. AB and CD. If those 2 are parallel, then that's our first pair we can look at. Okay. If they're parallel, what should our conclusion find? What are we going to see? They have the same slope. Let's just organize a little bit more. I'm going to put A down here. A is going to be -6, -2. B down here is going to be -2, 3. My C is going to be 3, -1. Your D is going to be -1, -6. So we're going to still need these formulas in order to help us out. Now, we got to use the distance or the slope formula. So the slope formula for this was y2 minus y1 over what? x2 minus x1. Basically, what you want to be able to think of is you're just subtracting the 2 numbers. Subtract your x's from x, your y's from y's. It doesn't matter which way they go as long as you're doing it the same. Now, my trick to this is we're just going to subtract them down here. -6 minus -2 is going to be keep, change, flip, which is going to give us a -4. -2 minus 3 is going to give us -5. And we're going to write it as -5 over -4. This is our first slope. If we do the other pair, subtracted them, 3 minus -1 is going to be 4. -1, I'm sorry, let me go back. We got to simplify this out a little bit more. This is going to give us 5 over 4, sorry. Got to make it positive. CD is going to be +4. +4 and 5. Again, we're going to have 5 over 4. Do we have parallel lines? Yes, they're the same. They're the same. So right automatically, we already have one pair. AB is parallel to CD. That's our first pair. Okay, if it was only one pair that was parallel, what kind of quadrilateral would it have been? Trapezoid. But we're going to show the extra pair to show that it's a parallelogram. So we're going to do the next pair. AD right here is going to need to be to BC. So AD right below it. And BC, sorry, not DC, BC. So again, I'm going to write the points. My point A is going to be at -6, -2. Bless you. D is going to be at -1, -6. B is going to be at -2, 3. And C is going to be 3, -1. So, doing the same thing, we're going to go and subtract out. -6 minus a -1 is going to be -5. -2 minus -6 is just going to be 4. So we're going to get 4 over -5. Then on top of that, we have one more thing where we're going to see that we're going to get -5 and 4. Just subtracting them out again. Again, 4 over -5. Are these two parallel? So we could say AD is parallel to BC. So is it a parallelogram? Yes. Bless you. Parallelogram. Two pairs parallel. Two pairs parallel. Now, we would just need to show them for this one, right? It's just asking us to show a parallelogram. But what happens, what about the top and bottom? What about the sides of them? Let's just look at the line AB and AD. Let's just look at the corner. Let's look at these two lines. What do those two have in common? 5 over 4, -4 over 5. Are they the same? Are they perpendicular?
Yeah. No.
Yes, they are. So these are perpendicular. So we're gonna do that today. We're gonna show that something is now both parallelogram and perpendicular, because these are opposite reciprocals of each other. This is 5 over 4, and the other one is -4 over 5. We said the opposite flip. We spent the day doing that. Okay, that means they're reciprocals. That means it's perpendicular. Okay, so here we go. Now, let's jump into this. Let's jump into this idea. You guys have the handout. Pull out the handout. Okay, we're going to pull this out really quick. Now, we're looking at now perpendicular lines, and so we're adding up. They're the same slope, they're parallel, we're good. The next thing we got to add on, we're going to add one thing to it. Now, you guys can directly tell me whether they're perpendicular by just saying, Mr. Aguilar, it's the opposite flip, they're perpendicular. I'm okay with you telling me that. But there is a mathematical version to this as well. And I'm going to show you that as well. It's not that hard to do, so I'm going to teach you it, and you're going to show you it. Two non-vertical lines are perpendicular. I'm going to abbreviate it because I don't got that much room. Perpendicular if and only if the product of their lines is -1. What does product mean? Multiplied. So if we take two slopes and we multiply them together, and if it gets us -1, they're perpendicular. That's it. Let's just look at a quick example. Let's just say I have the equation y is equal to 2 over 1 x plus 3. And let's look at y is equal to -1/2 x minus 4. What's our two slopes? 2 over 1 is our first slope. The other one's going to be -1 over. If we're to multiply these, we're going to get -2 over 2, or just, yes, that means they're perpendicular. And we actually want to be able to show that for all four sides. All the corners that make up a quadrilateral, we want to make sure that we're going to identify them as perpendicular or not. The first one's going to be trivial, but the next one might be a little bit more trickier, but it's, again, going to be easy. It's hard easy, I think. Hard easy. If that makes any sense. Hard easy. You just got to be able to match them up. Now, let's just jump into this first example. What does it ask us for us to show? As a rectangle. So do me a favor. On yesterday's homework, we had the chart. What does a chart tell me to look for if it is a rectangle? 4 right angles. So we got to look for the slopes. Okay, we're going to look for the angles. We got to first make sure it's a parallelogram, because if they're not parallel, we're done. So we're just adding on another step to this. Okay. Now, I believe you guys know how to do this, so let's go ahead and start. What is the slope of AB? Can we get the slope of AB? What would it give me? Up 3 over, so it'll reduce down to what? 1/2. If I'm going to do B, going down 2 over 1, our CD or DC, I always look from points left to right, so this is going to go up 3 over 6, again 1/2. And back into the other one, I'll just do it in black. We're going to go down 2 over 1, which is also 2 over 1. Negative 2 over 1, sorry. Now, we did the first step. That should be very easy for us to do. We should know how to do slope. If you don't know how to do it, come and see me after school. We'll practice it. Now, what makes it a parallelogram? 2 parallel sides. Do we have that? So let's just put that in there. We don't have to do that much proof to just say parallel. That means they're parallel. And we're going to say the top and bottom one is also parallel. So we did that. We're done with that. It's a parallelogram. We're done with that. We showed it's a parallelogram because we showed 2 pairs are parallel. Now, this is the extra step. This is comparing the slopes. We got to add on something else for this. And the something else we're going to add to this is we got to make sure that the corners are perpendicular. Let's look at this corner. Let's look at AB and BC. They're perpendicular. Are we sure? Let's find out. Let's say I want to look at AB. I'm going to do AB times BC. AB times BC. If it gives me -1, they're perpendicular. So what is my slope of AB? What about BC? -2 over 1. Multiply them out, we get -1. Is that perpendicular? Yes. So the whole thing up to this point should be okay. The only thing new that we're doing is down here. We're just multiplying 2 lines together that fit in the corner. And if they are, we say they're perpendicular. And we got to do it 4 times, unfortunately. So this bottom portion, let's look at this corner now, which happens to be what line? CB or BC and what? CD? So what is BC? -2 over 1. What is CD? If we multiply them out, what do we get? Are they perpendicular? Yeah. Yeah. This is simple, right? It's simple. We're going to do this 4 times. Is it redundant? Yes, but we still got to show it. Let's do the bottom corner down here. So we're going to look at this bottom corner. What 2 lines are we going to look at for this one? CD is our one side. What about the other side? DA? CD is what? DA is what? What does it give us? Is it perpendicular? This is all we're doing today. So we have the other right angle in this one right here, okay? We have to do one more, unfortunately. It's kind of redundant. Do we think it's going to be it? Yeah, absolutely. At this point, yes, it's going to be it. So what are our 2? DA and AD. AB, sorry. AB. And we're going to get DA is going to be -2 over 1, 1/2, -1, and they're perpendicular. Yes. No, it has to be. That's a redundancy of it. Technically, you only need to show 2 of them. And technically, you can only show the opposite corner. But I'd rather just have you show 4 just so you know. I'm going to streamline the next one. We're going to keep on streamlining this. I'm showing all the work just so you guys understand where I'm getting it. The other ones, we're going to get this idea where it's going to be freaking quick. Okay, I get that. Like, come on, do we need to do this 4 times? No, we don't need to do this 4 times. But just for practice and just to say what we're looking at, we want to be able to see where I'm getting the number from. Okay, consecutive sides are perpendicular. Since the product of the slope is -1, so consecutive means right next to each other, means next to each other. Give me a number, give me consecutive numbers. Give me 2 consecutive numbers, 1 and 2, 3 and 4, 5 and 6. They're right next to each other, so same thing applies. Quadrilateral ABCD is a rectangle. Because, made up a boo-boo on that, because it is a quadrilateral with 4 right angles. So by definition of a quadrilateral with 4 right angles, it is a rectangle, specifically quadrilateral. Okay, okay, don't get mad about that. Okay, is this hard to do? No, no. Only thing that we're adding on from yesterday is we're just saying whether they're perpendicular or not. And we're doing it several times. Okay, let's look at this next one. Let's look at this next one. Now this next one is a little bit more tricky. It's not by much. Not by much. Okay, now let's look at this. What type, so we got to read the question first of all. What are we looking for? It says JKLM is a trapezoid. So what does a trapezoid by definition have? Only one pair. So as long as we show that it has one pair, we're good. Okay, and then what else does it ask us to find? With what? 2 right angles. So we're going to show that it has one pair of parallel sides and 2 right angles. Done. We showed it. Trapezoid with 2 right angles. So let's go ahead just for extra practice. Can we show the slope formula and do this by every single slope? Yeah, absolutely. But we're not going to need it. I just want you guys to get practice. My point for J is going to be at -3,3. K is going to be at 3,1. L is going to be at 2, -2. And M is going to be at -1, -1. You guys know how to do that. Give coordinate points for those. We did a lot last year. At least I know my students did. Okay, that should be very easy for us. If it's not, we'll help you out. You let me know. Okay, now, do me a favor. Try to tell me what the slopes are. Can you guys do the slopes for me really quick? So you don't need to show me work from them because I understand you guys know how to do them. As long as you're able to tell me where they're at, please do that for me. Okay, tell me the slopes. I'll jump onto it right now. Just kind of do that for me real quick. I'm changing up my colors for me, guys. This is what we got. Is that what we got for it? Okay. Check your slopes for you. Are we confused about any of them? Okay. I'm just doing slopes from. You can do rise over run. It's always up and down to left and right. Okay. Yes. KL. Okay. Yes, it is. Sorry. It should be 3 over 1. Yes. Yes. Absolutely. Thank you, bud. Sorry. Yes. Oh, yeah, Jesus. Look at the big boo-boos over here, man. I am. -2/1, yes. Okay. Now, sorry, we're clear on that. Okay. Do we have one pair that is parallel? So let's put right next to it. It's a parallel. These two are parallel. What about the other two? So we're just going to say, we're just going to go no. I'll just cross it out. They're not parallel. So it helps us. Is it a trapezoid already? Yep. By definition, we have one pair that is parallel. It is a trapezoid. And we're going to put that right underneath it, trapezoid. Now, looking at your picture, and I'm hoping you guys can see it, do we have corners that look already perpendicular? So let's do those first two. Let's do our corner up here. Let's do these up here. So what's two of those? JK and KL. JK would be what? -1/3. KL is, which comes out to, this is perpendicular. Let's do the other corner. So I'm going to change up the color so you guys see where I'm doing it. I'm going to do the other corner down here. And let's do LM to KL. LM is going to be what? -1/3 to 3/1, which is going to be what? Is it perpendicular? Now, I'm going to add in these because I think we see what we're doing here. I'm going to add in these other two for you guys. So if I had to do the other two, JK to JM, if we do those two products, JK to JM is going to give me this. Does that mean it's perpendicular? 2/3? No. Has to be -1. Not 1, but -1. Okay? The bottom one as well, if we're doing the one down here, JM times ML, I believe that's going to give us 1/9. What conclusion can we make about the angles? 2 right angles. So the first part we did is we showed it's a trapezoid. The second part we did is we showed there's only 2 right angles. That's it. Done. Okay. Quadrilateral, JKLM, is a trapezoid. Good. With 2 right angles because the opposite sides are parallel. Opposite sides are parallel with 2 consecutive sides that are right angles are perpendicular. That's it. Is this easy or hard? That's it. That's it. Cool. We'll try it. You could try it. You could try half of it. That's good enough for me. The what? Yeah. I know it's $34 I think a year. So, but I'm more of a, if this is the only thing I have to worry about for a trial version, yeah, I'm using trial version. It's like Hungry Charts. I don't want to pay money for extra boosts. Basic. It doesn't have this. That's it. Right? I'm like, it's at the bottom of the corner anyways. If it was like in the middle, okay, I'll buy it. Bad marketing. Got it. Here we go. Now, so we're going to do those. So those are how you're going to do those. We're going to skip this one. We're going to skip this one, and we're going to jump to this one. Okay. This is another one that we got to be able to do. You're going to have a quiz question on this on Friday. Okay. I know. Scared. I know. Now, here we go. It tells us that we're given a Oh, come on, man. Okay, it's telling us that we're given lines for streets, and those streets create a block of a quadrilateral. Now we got to be able to determine what type of quadrilateral that is. So I'm not telling you determine what type it is. I want you to tell me how we're going to find this. The first thing it's asking us to do, and all these equations that look so messed up, we got to convert them into slope-intercept form. So Pine Street, we're going to convert. Negative x plus 2y is equal to 4 will be converted into y is equal to 1/2 x plus 2. So I'm writing in slope-intercept form. You should be able to do that by now. If not, you need to practice. Elm Road is going to be 2x plus y is equal to 7. I'm going to convert that one into y is equal to negative 2x plus 7. Subtracting over a 2x. Chestnut Street. That's going to be moved over. We're going to get y. I'm sorry. Let's write it out. 2y is equal to x minus 6. So Chestnut Street will be converted to y is equal to 1/2 x minus 3. And then the bottom one down here, Cedar Road, will be converted y plus 8 is equal to negative 2. X converted to y is equal to negative 2x minus 8. So they're all y equals mx plus b form. And we got to be able to graph them. We got to be able to graph them. So going up 2, up 1 over 2. We're going to graph this just to get an idea what it looks like. Elm Road will be up 7, down 2 over 1, down 2 over 1, down 2 over 1. So we're getting this look right here. We're going to do Chestnut Street, which is going to go down 3, up 1 over 2, up 1 over 2. And then we're going to go down 8, and then back up 2, back up 2, back up 2. So the inside portion of this is going to be our street that we're going to kind of look at. And just so it's going to help me out, I'm just going to label the lines. The top side of this is going to be my, let's give it different names. Let's give it R, S, T, and P. We're just saying the sides that are on that are going to be what we're going to kind of look for our slopes. And we'll do them in the same color that they're associated. So this will be P. This will be our slope for R. S will be in purple. Orange will be in T. Okay, just so we can kind of associate with that. First of all, what type does it look like? How about just what quadrilateral does it kind of look like? Square or a rectangle? Okay, we haven't done any squares yet, so it can only be a rectangle. Okay. The first thing we want to be able to see is that, do we have parallel streets? Is the slope of R and the slope of T equal? Are opposite sides parallel? Is R and T parallel? Are these two parallel? Are you sure? Yes, same slope. We're going to look at the slope. Absolutely. R and T are the same. What about the other two? Yeah, not the y-intercept. Then we also have that P and S are equal. That means we have parallels. Yep. Okay. The next thing we want to be able to see is, do we get perpendicular? So we got to make sure they're perpendicular. So let's do P and R. P and R, well, I'll tell you right now, it's going to give you -1. If you do P and S or R and S, we're going to get -1. If we do S and T, it's going to give us -1. If we do P and T, are these all perpendicular? So I know you guys can write it out, but we're going to save you guys some time on here. Okay. We have opposite sides that are parallel, and we have right angles. What can it be? Is it a rectangle? What would happen if we found that they were parallel but not perpendicular? Parallelogram. Parallelogram. Okay, rectangle. And so that's how you want to do those problems. That's how you guys want to do those problems. A good app to show you what it's going to look like to find your slope, Desmos. Download Desmos. That's a great app to still have. You can still use it. Okay? You can still use it. Okay? Cool beans? Homework time? Yeah? Here we go.